Hey there. All right. So today I'm going to give you guys a bit of a tour of the RStudio environment. I'm going to walk through with you guys a couple tutorials of how to generate several different kinds of plots. But before we do that, uh, first things first, we got to pull down our data set. And to do that, I went to import data set, and my data set was a CSV file. So I click that and browse and find your data set and import it like so. Once our data set is imported, first command that we run is the library function or library command for a read Excel package. And what this does is basically allows us to load and attach files so that we can open them and we can read them and work with them in the RStudio environment. After that, we see that I loaded a data set that is called salaries 2, and then we see over here where under data we see salaries 2 data set with 397 observations of 7 variables. A little bit about the data set that we're working with. The data set deals with the salary of different levels of professors in a college in the US. And by different levels, I mean whether or not they are an assistant, associate, professor, or full professor. And as well as the time since it's been that they had received their PhDs and how their salaries are impacted by their different rank or by the time since they had received their PhD. So we have our data set, which is salaries 2 currently. Then we have a push command with a dash and greater than sign pointing toward test data. And test data in this case is just allowing us to rename salaries 2 data. That way I wouldn't have to keep typing in salaries 2 over and over. So I rename the data set test data. And then our next command we have here is the attach command, which basically tells R that we want to actually use the file that we uploaded. And in other words, we're attaching the file, and that's the file that we're going to be working with. And so we see that I now attached test data. And we see that the only thing that's changed is the name of the variable. So what we're going to do is highlight these commands and click run. And then our first plot we have, which is a scatter plot, I'll go ahead and run the command and show you guys a little bit about what we're working with. All right. Oops. There we see we have a scatter plot of the professor's salaries since they received their PhD. We'll go back to the command here. We see we have plot, open parentheses, test data, which is the name of our data set. Then we have our $, which is basically saying, I want you to work with, which is basically telling R, I want you to work with this data set, and I want you to pull down this variable, in this case, salary. Salary would be our first variable, and since it's the first variable that we inputted, it is taking the place of our X variable. And then we have a comma, and then we have test data with another $, and then we have our new variable, in this case our Y variable, which is years since PhD. And we have a comma, and then we have a main command, which basically a main command with a title and or phrase in quotes. In this case, the main command tells R that we want our descriptor here to be the title of our graph. And then next we have our xlab, which tells R that we want to refer to the X value as salary, or that salary is going to be our X values label. And correspondingly, we have our Y value, which we want to label a year since the PhD. Now we have this neat little function, which is referred to as a PCH function. And in this case, we have PCH equals 24. And what this does, it allows you to change the type of data point or datum that you have in your graph. And in this case, PCH 24 tells R that we want to have our data points represented by equilateral triangles. And that is how we run and generate a scatter plot of our data in our RStudio software. And the next plot that we'll be talking about is a density plot. But before we do that, we have to add another package or run another package. So again, we have our library command that says we want to run an SM package. And once we run this package, it'll let us interpret the density function. And we see here we have sm.density.compare. But we'll get to that in just a second. So after we run the library function for the SM package, we see that we have a variable here, which is rank.x, and then we have another push command, and then we have a factor command or argument, where then we see we have test data, again pulling down the test data set, which we referred to as salaries2 before, right? So we have our test data set, then we have our $, and this time we're pulling down rank. And rank is going to be our X variable, or X value. And then we see we have levels, and in this case levels and the C command here refers to the number of levels that we have in our data set for the variable rank. And in this case, we have 4 levels of type of professor. Like we said, assistant, associate, professor, and full professor, right? And we see those here because then we have labels that correspond to each of these levels. And so 1 would be assistant professor, associate professor for 2, 3, 4, and so on. Right, and so basically, these are the scripts or the labels for each of these levels. Right, and then we run our main function or main argument, which is the actual density plot itself. And what we want to do is, and so that function is sm.density.compare. And again, we're pulling down the test data and working with salary in this case for our X variable. And then our second variable we're going to be working with, our Y variable, is where we have test data and our $, with rank. And in this case, because we're graphing density, well, let's go ahead and run it just to show you what we're working with. Right, so here we have our density plot, salary by rank, and we see we have our X label here, and then we have, of course, we have our title command or main equals command, which gives us our title, which is salary by rank. And then we have a cold fill command, which in cold fill refers to our, well, in this case it's a variable, but it refers to the color of each of our each of our levels here. So in this case, we have red, green, blue, and a light blue. But what I did here is push these commands, this level C, level 4 link command with levels, rank X variable, into a fill command variable. In other words, I'm saying I want my 4 levels, my associate, or yeah, my 4 levels of the variable to be labeled or to be colored. And then I gave the command to add in a legend, in this case, a locator. Legend command with a locator argument that says, okay, you want to add a legend somewhere in the on the table. So I just click, right click here, and we see we have the labels of our of each level, and we see assistant, associate, professor, and full professor for those labels. And if I were to change, you see where we have legend command locator. If I were to change that one value to a 2, it would say, okay, he wants to add another legend of some sort. But in this case, we just want the one legend. And then the fill command tells the tells R that we want to fill in those colors according to the colors that we have from each level. So we ran that command, and this is the density plot. Oops. This is the density plot that we're working with. All right. And then our last plot for this tutorial is a bar plot. In this case, we have a bar command. Well, I'll go ahead and run it again. Click run. There we go. In this case, we have a bar plot command and table. And the table function essentially says, I don't want you to just graph and input the data, say down here in the outcome or output function values console version of the table. I want you to put it in a table that's in a graph, and I want that table to be based on rank. And so we see here we have rank as our X variable in this case. Well, yeah, we inverted the table. So in this case, it would be our X label would be number of professors, and then our Y label would be rank. And in order to invert the table from a horizontal graph to, or I mean from a vertical graph to a horizontal graph, the argument that we would use is HORIZ equals true. And that's how we were able to invert this graph here. All right, and I didn't mention before, but we see here that we have our values, which in this case we have cofill, the PHC, or PCH rather, value, and our rank.x variable. And these are all the values that correspond to what we asked R to do and the functions that we asked R to perform.